Hi guys, you hear me?
Yeah.
No or yes? Yeah. Now? Great. Okay, okay, this is a bit too loud. So I'll be giving a talk about Effortless Serverless, as you can see. My name is Alex. I'm from Serbia. This is my first time in Ukraine, so I'm very curious to see and interested. So we can start. Yeah, I'm a software consultant. I'm an organizer of JS Belgrade. So yeah, you can find me on Twitter and GitHub as well. So we'll be talking about Effortless Serverless. Sounds a bit like shitty, right? No servers and no effort. Bullshit, actually. So I'm going to start with a story. It's my personal fail story from my own company and everything. And it's a startup where actually I worked for a couple of times, and well, it was a magical startup, a unicorn. A lot of stuff, a lot of money involved, a lot of VCs, everything, all those magic words when people say, oh, we're innovative and everything. So we were building apps. I hope I don't see me. So we were building apps, and it was an educational startup. We have a couple of front-end apps. We have an API, a Postgre, whatever, you know, a lot of services. And as you, everybody loves. We as engineers, we love to create software, but sometimes we forget that we need to serve our customers sometimes. So, this is what we use to serve our customers mostly. We were hosting our apps on Heroku, Amazon, Azure. Of course, probably a lot of you can identify with environments like development, staging, production, and probably a lot of companies does it that way. But then you also need to, organize the serving of your customers. So you take your applications, you set them up on separate servers. Depending on their usage, so you put your front-end apps, each and every one of them on a separate server. You have a big server for API or some other services that you're using. But that can be a problem because sometimes you have to have, if you have 3 environments, you have to have times 3. In our case, it came up to 15 servers for a starting startup. Later it evolved, we had even up to 30. And then you have to do some planning also with your applications. So you have to do capacity planning of your applications, like how many customers are you going to have. You have to rent and configure your machines. Everybody did it at least once in their life. You also need to deploy. How many people here still SSH to their server or rsync? Raise your hands, please. Yeah. So then you also have to do scaling and balancing. So if a lot of customers come, you really need to plan for a lot of stuff. And it sounds normal, right? It sounds like something that, yeah, it's something very logical. But in reality, what happens is, yeah, because the reason for that is you cannot expect everything while you're building applications. You cannot properly plan. So, for example, for us, we had a problem with the marketing. They said they didn't communicate with us, and they put an ad, and all of a sudden, in 1 hour, 100,000 users starting using because they put a large-scale advertising everywhere, and it completely crashed our application. Then they were like, yeah, we're going to be better next time. We are engineers. We can really solve everything that comes to our way. Well, I turned it off. So Yeah, what happened next time was, it was just 1 month later. We had an overflow of our Elasticsearch server. So what happened was our API crashed, then our users crashed, and then we had our boss telling us, you're a bunch of incompetent morons. But again, we said next time will be better. Of course, we learned from our previous experiences. And then 2 months later, we had a DDoS attack. Yeah. 48 hours, customers were screaming at us. They decided not to pay anymore and everything. And then 3 months later, well, it's a problem. But then management asks us always, like, yeah, but why not just get bigger servers and you can estimate better? I mean, this is your job. You're doing this job for 10 years now. I mean, how can you we're paying you a lot of money. You need to be able to, yeah, but you cannot predict, for example, a snowstorm in United States. So, for example, some of your servers are over there, they're going to crash. I mean, you cannot predict a lot of stuff. So you're like, yeah, no problem. Thank you, man. Yeah. And bigger servers, when you organize them, yeah, it looks literally like this. So because you have to put each of your application, one at a time. I mean, usually as if you're doing, for example, backend, you tell your front-end developers, hey, wait till I put my API first, and then you can put your API, then you can put your front-end app, and then let's see how it works. I mean, a lot of stuff. So, yeah, we ended up with a total cost of $3,000 per month of application servers. We are not speaking about our databases. We're not speaking about our storage. We're just speaking about so per month, that's a lot of money for a company. I mean, it is. So, it came to, basically if you put it up in a flow, more customers is like more servers. More servers means more complexity, and more complexity, well, more problems. But somebody will probably ask, if there's somebody here from the management, they're going to be like, okay, why are more customers more problems? Isn't that actually the opposite? We want to have more customers. We want to have more people involved. So we did some analysis, and we were like, okay, let's see how are we using our average API. This situation is applicable to any person using servers and deploying to servers and everything. So yeah, maybe it's a bit, some people in the far cannot see it, but at the bottom, at the horizontal bar is the intervals during the day. So you have from the 6 in the morning, 9, 12, till the other day. And this is the average API server usage that we analyzed and we estimated. So in the morning you have a very few amount of people, it gets used a lot afterwards and everything. And this is cumulative, this is just between those 3 hours. So we are not measuring peaks and everything. So we were like, yeah, this is normal. This is an average server that we pay for $100. But what if we change the perspective? This is actually the opposite perspective. So this shows the wasted time of your server. This shows everything all the money you're throwing away. So you look at this and you're like, okay, but it's not bad because this is how we used to do it. But so is this how you used to do it? Our average is 63%, let's say, of wasted resources. You're throwing away literally money. You're literally throwing. You can see in the bottom, maybe some on the back cannot, but it's almost $2,000 of those $3,000 for application servers that we are throwing away. So, okay, what do we do in an average API when there is an unexpected peak? Like, for example, the situation we said, I mentioned at the beginning, where you have 100,000 new users coming immediately. So in an average, in our situation, what we did was, okay, this is our usage, unexpected peak. So we said, okay, this is what happened. Let's put a bigger server, so our capacity is somewhere before, so let's spend more money, let's spend it. Because why not? The management told us, yeah, we should make a bigger server. So what you do is you put a buffer, you say we're going to have maybe 30% more customers than the previous peak, and we are safe. You know, I mean, what's the chance that we're going to again have 100,000 users coming to, 200,000 users coming immediately? I mean, that's a very low chance, right? So we were okay. So then some they say you need more servers. When they ask you, okay, we need more servers, you need to do it. When then, of course, is this situation. Yeah, let's spend even more money because we're a $1 million startup and we are doing it. I mean, why not? We have money. So these are the usual issues that we came to identify. So with servers, usually you have most of the time waiting for a request. You have a maximum capacity. One service can eat up your whole memory and can cause the whole system to crash. You have a recovery time from 2 to 7 hours. For some startups, it's actually faster, but it depends. For example, in our case, we had students from Indonesia, which had the test in the 3 a.m. on our time, and then the server crashed, and for 7 hours, they had a test, actually then at the paper. I mean, they were customers. So after 7 hours, we managed to back up the application, set everything back. I mean, this was in 2014, just to be sure, just to clarify. And then again, you have to call the DevOps guys. You know, you have to call the DevOps if, for example, your server is stuck or whatever. For example, if you have a big server, let's say, I don't know, a huge server, and you have, for example, an Angular app or 2 apps you put on a server. Sometimes it's stupid just to put one app on it, or you know, you're like, I'm wasting time. And again, renting a new server if you want, this takes more than 1 hour. So what is this similar to? Yeah, this probably sounds super weird, but let's take a look. So a washing machine. Servers are actually quite identical to washing machines. They are processing machines. Where, as with washing machines, you have different clothes. You put them in. You have a maximum weight. After some time, the machine gives you back the result. It finishes whatever you requested and gives you back clean clothes. It can be smaller, then you can put a small stuff, even put one on, or it can be a lot bigger, so it can handle a lot more stuff. But it also has issues. You all probably can identify. So it's mostly waiting for clothes. It's sitting in your bathroom, literally. It has a maximum capacity, 5, 10, even 20 kilos. One cloth. So, for example, if you put your special Princess dress with your pants, it's probably going to get ruined. Then recovery time, it can be up to 1 day if it breaks. Then you have to call the plumber because sometimes you cannot fix it, sometimes you can. It can flood your bathroom. Buying one takes also up to 2 hours, and it's cheaper to wash one shirt. So, yeah, kind of looks like how we are deploying our servers, right? So let's make a comparison. So can it be the same? So mostly we are waiting for clothes, or requests. You have maximum capacity. One service can kill up the other service. You need to call the plumber. So basically they have identical behavior, identical issues. So, okay, how did the laundry industry solve their issues? I mean, we can learn from each other, believe it or not. So we have a first laundromat, 1934. Does everybody know here what's a laundromat? Do you know? So you go there, you go to a laundromat service, you put a coin, and your service gets washed, you rent it for that time, and then you go home, and that's it. So that's what happened 100 years ago almost. The first laundromat, then we had mass laundromats, and then we had the first fluff and fold. So the fluff and fold, I'll explain what it is. It's a cleaning service with pickup and delivery, where you pay per item, they come to your apartment, and they pick up your clothes. You can give one clothing, like a sweater or whatever. You can put it, they clean it, and they return it back to you. You can have 1,000, they will take all of it. If you have one, take one, it doesn't matter. So So fluff and fold actually means that you no longer care about washing machines. You no longer care about their detergent. You don't have to know anything about them. It also means that it doesn't have maximum capacity. So you don't have to, for example, I mean, if you can identify that sometimes you can just like have one shirt that you want to wash, then you're like, yeah, but I cannot wash just one shirt. Let me see what other stuff I need to clean, so you need to pack it all together. And yeah, with fluff and fold, you don't have to do it. You can just call, I have one shirt I want to have clean, and that's it. So how did our industry evolve? With the servers. We had the first VPS, virtual private servers. And then we have the mass VPS in 2005, the cloud. If everybody remembers, like, oh, you can put things on the cloud. Yeah. But what is our next step? So is this serverless thing, what people say, like no servers, our new fluff and fold, or something that is the next step in our stuff? Or is it a bad advertising, just like this? Yeah, this guy is selling a deer. A gray deer. So what is serverless? So basically, if we took it in a comparison with our washing machines, so it's a method of running and deploying software without renting or buying a server, and you pay per request or execution, and you can scale your services from 1 to 1,000. So serverless means that you also, I mean, if you put into comparison, means you don't need to worry about servers and you don't worry about server configuration. It also means you don't worry about scaling and you don't worry about balancing. And it also means, again, you don't worry about the capacity. You don't worry about DevOps. Now this is a bit of a tricky part, but we'll come to it later. So serverless. But serverless is a very weird name because it does not exclude the existence of servers. I mean, for serverless, you need to have servers. Your software needs to be run on servers. So how is this serverless? And yeah, the serverless has a shitty name. I mean, some people actually call it Jeff, just because it's much more similar than serverless. But so how does it actually work? So basically, serverless is, instead of having, like, probably a lot of you are well aware of Docker and containers and everything. Well, this is a very micro container or a function container, literally like a plant pot. So it's a completely set up environment by the provider, and you don't have to worry about anything. You just need to worry about your code. So the serverless has auto start, which means it has your function sleeps, so it has no cost when it hosts. The function is sleep. You don't pay when it's not used. Your function is sleeping, literally. You don't pay for hosting. And only when a request comes, like only at that time, it rises. Compared to, for example, a classical server rental, when you pay for reserved time. So you reserve a server. So how does that actually help us? Let's say, how does that help? So it helps with event-driven function scaling, which means, so your function sleeps. When a request comes, it wakes up, it does it, and returns gives back a response, and it again falls asleep. If you have a lot of requests coming, then your provider automatically scales the quantity of function containers that you have, that you need. So it also helps you with emphasizing restructuring and microservices. Okay, let's see how does that to actually work. So this is for example, a classical server-hosted API structure. So let's say you're doing an Express app with Node.js. How many people know Node.js and Express here? Can really raise your arm? Great. So you're probably quite you're going to be familiar with this. So you have your API endpoints in your server.js, and then you have a lot of controllers. You have a database, file storage, and this is your API. This is how you develop a Node.js app. So I mean, each of these small squares represents a certain aggregated function. Like, for example, something like getting users, retrieving users, updating users, whatever, you know. And so how do you scale this? I mean, you scale it like this. So you reserve multiple servers and you scale everything. But with serverless, it emphasizes such structure that it puts you in, that you create each of those smaller aggregate functions inside a small microservice. Because, I mean, why would you don't need to have everything because you're not using everything. So when you scale it, serverless API, you scale it like this. All of your, for example, you put a function for products. The products is the one you use the most. So why would you scale, for example, users or payment along with the products? Because your customers are mostly focusing on your products, on seeing a product, reserving, maybe paying, logging in, orders. But for example, some are not even used at all, and everybody, I mean, including myself still. Everybody's still scaling everything all together, like a bundling everything, and it doesn't matter if we need it or not. I mean, this is our API. Serverless means you don't pay if no one is using it. So you only pay for what is being used. So these are the providers, for example, for serverless. As you can see, these are high-level players if you wanted to get aware of that. So you have Microsoft with Azure Functions, you have AWS Lambda with Amazon, you have Google Cloud Functions, OpenWhisk, and everything. And I will just tell you that all of this has started even from 2014. So this is the pricing. If anybody is interested, like to see what's the pricing. So as you can see, it's per request. It seems a lot, but you have, for example, 1 million requests per month free. The next million is 20 cents. So can somebody of here tell me if they have more than 1 million per month requests coming to their API? So with Azure, you have, this is at the current presentation state. So they pay 0.0016 gigabytes per second. And basically, they do also by request, by execution. So they charge you by execution time. So as by use time. It's similar with Lambda. As you can see, the pricing is very similar. 1 million per month is free. So okay, so you're probably thinking, okay, what programming languages can I use with serverless? Well, in AWS Lambda, you can use, as you can see, Node.js, Python, C#, Java. With Azure, you can also use F# and you can use PHP. Okay, so let's see an example. How does a serverless app look like? It's too much theory. Let's see some practice. So this is a hello world function on a serverless function. Hello world serverless function. As you can see, it's very, very simple. So, okay, how do you deploy it? I mean, how do you work with it? So usually, how do you deploy your regular API? For example, some people pack it, zip it, some people have a GitHub on their server or whatever, so you log in, you pull your server, you prepare it, whatever. Some people zip it to their server or whatever. So it's very similar with serverless. So you can just implement your function, you zip it, you upload it to your provider, then you create an API gateway. That's how with serverless goes. You set triggers and permissions. This seems a bit like complicated. So people have created actually tools to help you with it. So you can do it with one command. With Amazon, with SAM, CloudWatch, Serverless Framework, CodeStar, Apex. There's a lot more. This is mostly focused on AWS. So I'm going to show you I'm going to show you also in this next part, like how do you do it with CloudWatch. What is CloudWatch? It's a tool to help you create your serverless functions. So you can deploy with a single command. There is no boilerplate. You can use standard NPM modules, multiple versions, whatever. And this is how an API looks. It has an Express-like API, as you can see. So migrating your, for example, classical app to a serverless one is very, very, very easy. And this is how you deploy it. So you do a single command, and your application is instantly deployed. This is what you get the result in the console. And for example, this one, if you went there, I mean, if somebody's interested, I will probably put the link afterwards. So it immediately gets started, and it displays Hello Kharkiv. So as you can see, this is all the code, the whole API. So quite effortless, huh? One command, and it's all done. So yeah, doesn't seem way bad. So, but why is serverless important? So let's look at that. So it provides you auto-scaling. So if you have a lot of requests, it automatically gets scaled. Your provider automatically manages that for you. You don't do anything. You don't set the balancers. You don't set up any kind of other different setup. You don't do anything, like literally. Then, and if you have 1,000 or 2,000, 10,000 requests coming, it scales exactly to serve all those 10,000 requests. And if in the next step you literally have no requests, all of the functions go back to sleep. So there is no running services. There is nothing. Then it has improved stability and auto failover. So what does that mean? If you remember from one of the previous slides, when we had multiple microservices set up, if, for example, send emails fails, your API doesn't crash. All other services are working, and they're going to be properly set up. If, for example, your function fails, it also gets automatically reset. It automatically is a new one is created instead of replaced. For example, if you have like 5 functions and one of those 5 crashes, it doesn't, and another request comes, Amazon doesn't care, for example, or Azure, they don't care, and they just set up a new one to replace her. Then serverless, actually, this is for me the most important one, and I cannot emphasize enough why is this important, because it focuses on business logic. You don't do this configuration anymore. So what we did, we spent in my fail story, we focused a lot on configuration. Like, okay, how are we going to serve these 100,000 customers? How are we going to do it? I mean, it's not easy. I mean, when you start first, you love to build apps, but then it becomes a mess. You start being more a DevOps guy than a developer, and it's a bit annoying. So yeah, it's painful. But with serverless, you also can now focus on business logic, and you have minimal maintenance, which means you don't think about if the service is going to fail or not, if something's going to happen if you have a lot of people coming in, and it costs less. So you have you are going with serverless, you're going from reserved time. So when you go to buy a server on DigitalOcean or whatever, you basically reserve all of its time, and you pay for all of its time. While with serverless, you just pay for the use time, only by the requests that have come to your application. So they have become a commodity. A commodity is something that you basically use every day, and that it's integrated in your life, like water. At the beginning, if you remember, even with water, we had like buckets, and then we had water reservoirs and everything, and then now we have plumbing inside the house. You just open and there's water in your house. I mean, 300 years ago, nobody could think about something that you would have water inside your house. Only the richest people had it. So, but you're probably now thinking, okay, this guy is selling too much. Okay, there must be a drawback. So serverless is not good for real-time applications. So I mean, with sockets. Like if you need to have like an open socket, at the moment it cannot support it. So you need to use some compute container or something else. If you need to have like extremely low latency apps, I mean, the last one I heard about that couldn't use serverless was an airplane industry, like people who were thinking of using serverless in airplanes. Whatever, but okay. And if you have long-running tasks. Because your function containers just lived for a certain amount of time, because they need to just get a request, process it, and return it back, you cannot do a long-running task with it. Each function has a limit. It has a limit maybe to 5 minutes, 3 minutes on for example, for Amazon. You have 3 minutes and that's it. And then it goes back to sleep. So I mean, there are hacks people have managed to create a function that invokes another function so it stays alive. It creates a request so it stays alive, but it's not still so good for it. If you have a long-running task, such as processing a video, then it's better to get like a compute container, and it's just going to finish your processing and that's it. But for APIs, no. Very specific configurations, if you have, for example, if you really need to have something very specific inside your app, then you're not going to probably want to use serverless. I mean, very specific means, I don't know, you're keeping something very weird in your app, I'm not going to mention what. Or if you need a SLA, you know, if you need to have let me explain it, like a secure layer. I mean, also in a way that secure services, in a way that your service is going to 100% uptime and everything. That's what I mean. And okay, let's see what is it good for, because I mentioned the bad stuff. So the majority of stuff. So web APIs, microservices, chatbots, IoT, if you want to do file and image processing, or rapid prototyping and everything. So yeah, that actually covers 90% of the APIs. So there are also hidden benefits. And hidden benefits is that serverless helps you focus, it helps you with refactoring. Why? Because now it actually makes sense to refactor your code, because now you're paying by utilization. So if your service is running longer, you pay more. If it's very fast, you pay much less. There is no, oh, this is enough, it's going to do the job or whatever. Now you're focused on actually paying as least as possible, which comes to code efficiency. So serverless focuses you to have a more efficient code. So that, for example, a slower code can have much bigger repercussions. So, for example, one function can run for like 10 seconds, and you're going to pay for those 10 seconds, while one function can run for 200 milliseconds, and you just pay like those $0.000.4. If you're wondering, like, what's in production, a lot of stuff is in production. For example, with CloudWatch, for example, CodePen is using it. Does everybody here know what's a CodePen? Yeah. So if you're using CodePen right now, CodePen is on serverless. So it's using CloudWatch for pre-processing, like, for example, for your SAS or less or whatever. MindMap is a large-scale mind mapping software with over 500,000 people. They have migrated to serverless 1 year ago. Autodesk, yeah, like Katia and all that kind of stuff. Yeah, they're also using serverless. Shippo, does anybody do shipping here? A lot of stuff. Well, Shippo is like a startup that does that provides shipping services to you, whatever, and they are now serverless also. So, in summary, serverless means that actually it comes with no server configuration. It literally has less cost. It has auto-scaling and auto-failover. It's pretty effortless with CloudWatch. And it's event-driven, so you no longer function on constantly running software. When an event appears or a request comes, your service gets started immediately, and it works great with Node.js. Yeah, this is exactly a server rack. So if you want to learn more about serverless, there are serverless camps. My friends and me, we are organizing some of them. This is serverless tank wars. You create your first serverless function and while building a tank, and there are 8 teams and they all fight together, like whose function is going to be the fastest and is going to be the one who wins. I mentioned with a friend I wrote a book called Serverless Apps with Node.js and Claudia. So I managed to convince my publishers that there is a promotional code just for the conference, and that's it. Thank you.
Thank you, Aleksandar.
There's a guy over there.
Questions?
Thank you for your speech. I have a question about slide with where should we use it. Could you please?
This one.
Yeah, about file enrichment purposes.
Yeah.
We're using serverless on our project, and we found an issue with limitations of body size.
Of?
Body size. So
Body size, okay.
we cannot send big images, and because of Amazon API gateway limitations, we cannot use it.
So our way of, for example, we created just a service for resampling images as well, and to bigger ones, to smaller ones, whatever. So what we did, we uploaded to S3, because your Lambda, you don't need to upload it to your API gateway. You can use it, you can create, for example, a user on, you can create a policy on Amazon S3, you upload your picture there, and the S3 can create an event for Lambda so you can process the image. And so you don't need to go via API gateway. So you can literally just put an image to S3 in a temporary folder, it processes it and returns the response to your user.
Okay, thank you. And also, we have limitations on request body and also on response body.
Yeah, but you can return the whole image as a stream. So you don't have to do it also via JSON. You can use it with a stream, and it can pass to your function. There is no I don't know how big images are you processing, but we've done even 20 megabyte images with no problem via S3, of course. If you have any questions, if anybody has a question, I'm going to be also in the speaker corner after this talk. So, yeah.
And before next questions, while Mark is doing there, so there will be Simovic, Gavrilo, and Martishny in the green stage downstairs on the second floor, and you are all-inclusive KharkivJS conference. So after next speak, here will be a single say with his speech on security. After that speech, you will have a free lunch on the first floor. That's it. Questions?
Yeah, a bit closer probably. Sorry?
Thank you. It was very interesting.
Thank you.
Can you please compare serverless framework and CloudWatch? Why use Cloud?
Okay, I'm going to be a bit of a shameless promotion. I'm one of the authors behind Claudia, so we are, so I'm usually wanting to push for that, but we are actually having great cooperation with Serverless Framework. Serverless Framework is great. The only difference is that we have no configuration. So comparing Serverless Framework with CloudWatch is with Serverless Framework you need to set up a config file, a YAML file. It's great. The benefit of the pro of Serverless Framework is that you can deploy to various cloud providers. With Claudia is only AWS. But on the other hand, with Claudia you have no configuration. You don't need to set up a configuration file. You just do Claudia create, and that's it. And it's going to be set up in the region where you specify, or whatever, like a policy or whatever. So basically, you don't have any configuration files. That's the biggest difference between those two. So also, if you want to do like huge services, like where you need configuration, then you want to use serverless. But if you're doing APIs or bots or like normal, let's say, stuff, then a lot of people are actually very, very happy with the CloudWatch. Yeah.
Thank you. I have a question about debugging of those functions, especially when they are deployed to OS Lambda. Sometimes it's possible to debug them locally, but it's not the same as they are deployed to the OS. How you are debugging deployed code?
Okay, so first of all, you're probably using CloudWatch, right?
I don't use Cloud, I use
CloudWatch. On AWS, you have CloudWatch, the service where you have your log. You just put a console log and you can see your responses. Is this your question?
Yes, but this doesn't cover all cases because I faced a case when I wrote a function, I deployed it, but for example, it doesn't put anything in console log. I don't know why.
Yeah, well, usually console logs are usually set are usually written in the CloudWatch. It's like a AWS service, but you have to be careful about the region, because sometimes if you go to a different region, you will not see your function. Because, for example, it happened to us a couple of times. We had a problem that we deployed our function. There are no logs, but then we realized we messed up the region. We went to a US region instead of going to the EU Central. So you don't see the logs and you're like, okay, what's going on? But actually the logs are there. You can also use AWS CLI. It's a command line tool where you can trace those logs so they can come to your console instead of going to the CloudWatch. So these are the ways I suggest that you do it. The best is via the log, in your terminal. So you trace them. That's the safest for us right now. Or you can do there is a local way to test them also. With serverless, you have serverless local, I think. And with cloud.
Yes, but as I remember, it emulates environment and doesn't work perfectly.
It doesn't have 100% emulation, but I think now with AWS you have the serverless SAM tool and everything, so you can try it. I mean, we'll talk later in the speaker corner, so we can talk a bit more. Thank you.
About starting assets, databases, and etc. They still should be handled differently on the other servers, I guess. All the other stuff which is static, like files movement, apps, databases, some maybe images or etc. which you're processing. You still pay separately for them, yes?
No. Actually, a lot of these providers, already have, you can use your separate servers, it's not a big deal, but the focus is you want to really have a truly serverless app. So all of these providers have you have Amazon S3 for file storage, and the benefit of using it is that you have events. So when a new image comes, an event is triggered to a Lambda, so you can process it as with S3, your code, you don't pay for hosting your code at all. So your code stays and you don't pay for anything. But for your files, you're only paid for the storage you use. For example, even with Amazon S3 as a serverless container, you only pay for the files for the storage you're using, not the whole server.
Okay, and the second question is maybe I will go to you on the speaker corner. Is what general steps should be done to transform general service Express app, when you have a number of Express app and you have 8 app, each sign up to this serverless.
Okay, so
maybe more explored, maybe it's better.
I will tell it very shortly. So usually we tend to, what we did, we analyzed our code, which was used the most. And we first extracted those parts because, for example, a lot of us are using Express still. And Express is very similar to Cloud API Builder, how to build your API. So we just took those services first to AWS Lambda. And we did keep because we did it in a step-by-step way. So we did keep a separate server, with the same API, but we managed to switch some of the requests to the Lambda, and we did a step-by-step way. First, the services that are mostly used. So because we want them to be scaled as much as possible, not the whole API.
But do you need to, I guess, replace the suite stuff from the Express to this new package?
You don't need to have any. You will not have any problems because it's literally the same. Everything works the same. So, I mean, we'll talk about later. I'll explain to you in detail how we did it. Thank you.
Thank you for the speech.
Thank you.
In the end, the whole picture we have actually benefit for end product for our customer because we don't pay money, we just develop and our customer pay money. And I agree with previous question about development process. It's now a little bit difficult because we have some problem with debugging, with logging, with understanding how this process running on the Amazon base because it's not local development.
You can have local development even
Yes,
now.
but sometimes it's difficult to understand how can. But my question is how do you solve problem with different environments? For example, in the usual way we have test environment, product environment, development environment, and it is three different servers.
Yeah.
But how we solve this problem in these servers?
Yeah, you can have, for example, I mean, I'm gonna speak very sharply about Cloudia right now at this moment, because you can just add a tag version. Versioning is done very fast, like very easily. You just add a version, and you can name the version like staging. And in your deployment script, you just say, I want to deploy to the staging environment. It just adds / version staging, and that's it. The same code is over there, and if you want to switch, for example, from a stage, the same lambda or same function to a different function, to a different environment, you can just do like you can just switch the version literally. You can even say this is the latest version, this is the one I want to use, and that's it. The provider will provide this one, for example, the staging version for a production one. It's very simple.
Also, you just concentrate on the way to different versions.
Sorry?
Concentrate on the way to see the different versions.
I didn't understand. Sorry. Well, basically you can do this with Node.js very simply. You can CloudWatch is mostly just for Node.js. It's not for Visual Basic. I'm sorry. But
last question. What you do is cold start.
Yeah, so cold start with Lambda, because, for example, the cold start for some people who maybe are not familiar with it is a situation where none of your services are running, none of the functions, and a request comes. So how fast can Amazon run up your Lambda? Well, in our experience, it's usually around 1 second in our experience, but it can be up to a couple of seconds, maybe 2 or 3 for the first one. After it goes super fast. But some people, they have a warmer. This is how they call it. So they ping their service maybe once every while, and 10 seconds if they want, or 10 minutes if they want to keep it alive. Because you don't. I mean, this is the benefit of serverless. You don't have to worry. You don't think about servers anymore. But some people, they still like to. They ping a service to warm it up, so it's still there in the Amazon cache or whatever it is, you know. And so this is how they solve the cold start. But if 1 second, if 1 second is too much, then it's a bit of a problem. But we can talk about it later.
Все, ребят, простите. Теперь, если у кого-то остались вопросы, Саша, вниз, второй этаж, зеленый зал. Спасибо, Саша. Саша, еще раз.
Yeah, okay, thank you. Thank you.